Alright, so number 2, first part's an easy one, yeah? Find the velocity, yeah, so you just take the derivative.
So what's the first step?
Find the velocity is the derivative of position, so this is 0.04 e to the third minus 0.12 squared.
So when you it's so great for the people who like writing down in words what the step is.
Well, you see now you're A, B, C. And then after that.
Yeah, because we talked before,
Yeah, but I just like this.
yeah, so velocity is the derivative of position.
Yeah,
Okay, so
I
we
just
took
like
the
it.
derivative. Okay. So then what is the velocity after 3 seconds? So you plug in 3 t. And when you get to that field? 0?
Do the exponential coordinates.
For real? You got 0? Did you get 0?
Yeah.
0? Okay, when is the particle at rest? So that means take the velocity equation and set it equal to 0 and solve. One of them we know it's going to be 3, okay? The way I would solve this algebraically is I would factor out a 0.04 t squared. And that would leave me t minus 3 equals 0. Because 0.13 divided by 0.04 is 3. And so then you know the velocity is 0 at t equals 0 and also at 3.
Why do we know this one? Why is 0?
Because
Never
the
mind.
Where does he
Throw it out there.
okay, the t minus 3 came from because if you go 0.12 t squared divided by 0.04 t squared, you get 3. Yeah, because I knew 0.04 goes into both of these. I mean, you can just think of this, we could be doing that with 4 as well. 12 divided by 4 is 3. Okay, when was the particle moving in the positive direction? So this is where we get to make that fun sign chart. We got 0, and then we got infinity, and then we got 3. So we know that at 0 and at 3 it's at rest. So just pick a number. 2. Plug that into. No, we can't use 0 because because 0 is one of our inputs. Okay, so 2 or 1, whatever. So take that and plug that into the velocity equation. Okay. Which one? You said 2, you said 1, and 1. Okay. So that would be 0.04 minus 0.12 would be, what did you say? When you put in 1, what did you say? What did you get? Oh, that would be, sorry. Negative 0.2, that's the important part is that it's negative. So back here, since we plugged in 1 and got a negative answer, that means all of these things are going to be negative.
Oh, I remember this. And then the stuff on the side positive.
Exactly.
And then it goes in that
Right, so just alternate. Well, below 0
So
it
is it
doesn't
like 0 to
exist.
3 is negative, and then like 3 to 6 is
Yeah.
positive?
Well, that's a different conversation. So for D, it says when is the particle moving in the positive direction? So that was from 3 to infinity, right? Yeah, but there weren't any other zeros, so it's not going to alternate anymore. If there was another place where it equals 0, then it would, yeah. Right, then it would be from 3 to 7, and then from 7 to infinity would be negative. Okay, find the total distance traveled during the first 8 seconds. So this, Mackenzie, is the first difficult question. Okay? So to think about the path of the particle. Alright? Ready? Okay, so from 0 to 3 it's moving to the left. And then from 3 to, when do you want to figure this out? 8? total distance that the particle has traveled, we have to find the length of these two segments and add them together.
And that's -3, right?
No, these are the velocities.
Okay.
But to find the length of the segments, you have to use the original position.
Yeah, I know.
So at time t equals 0, if you plug 0 into the original equation, then you find out that the particle is at 0. So at time t equals 0, it started at position 0. And then if you plug 3 into here, no, that's the velocity. Right, we don't plug it into the original one. So I don't know what 0.01 times 3 is. Really? No, I grabbed it and put it on here. No, I walked over to my desk and put it on here. So she actually got up. Negative 0.27. Okay, so anyone confirm or? Yeah. You got it? Wait, yeah, you got negative 0.27? Okay.
And then for 20.4.
20.4. Negative 0.27. Okay, so now plug in 8. Hey, crackhead! Put the drugs away. They're ruining your life. They are controlling your life.
Yeah, one of them was that.
20.48? Yeah. 20.84? Okay, so from 0 to 3, it traveled a distance of 0.27 feet. Okay? And then from 3 to 8, it traveled a total distance of 20.75. If you were more engaged with the problem, if you understand that we're only halfway paying attention,
So it
because
doesn't
most
matter.
of your attention is on the
I know,
stupid
I didn't
game
add it,
that
I
you're
didn't
playing.
add it yet.
So it doesn't matter that it's
It matters that it's negative because that is what told us to add these and not subtract these. We started at a negative position and moved to a positive one. Either this minus a negative is zero.
Okay, why is that 20.75 right now?
Because this plus this makes
Yeah,
what?
but you said,
Except there's another one.
That's this one right here. So that's a total of 21.02 feet.
So how is it positive 27 when you subtract it?
Huh? I did that. I did not.
Oh my gosh!
F, draw a diagram like previously to illustrate the motion of the particle. We kind of already did that in my little arrows. Okay. G, find the acceleration at time t and after 3 seconds. How do you find the acceleration? Good. Take the derivative of the velocity, which is this guy right here. I didn't say that. So that's the acceleration at time t, and then for 3 seconds, you plug in 3. Long. Put it online. Yep, that's what you got. Alright, then for h of says graph the position, velocity, and acceleration functions. I don't want to graph the position one, but we do unfortunately have to graph the very original one is the position one. No, that just makes things more confusing than they need to be. Okay, so the velocity one is 0.04. Minus 0.12. Oh, yeah, that'd be awesome. And then what? I could probably just put the deal in there. So 0.12 x squared minus 0.24 x. Okay, and then our window. Whoa. Because we were doing a problem in math analysis about a submarine that was 1,000 meters below the. Well, we knew that, right? We knew that it was going to be negative from 0 to 3 and then be positive. Okay. So here's the speeding particle. Right? The particle is speeding up when the velocity and the acceleration are both positive or when they're both negative. Both. And it's slowing down when they're opposite of each other. So that's why we're looking at this graph, especially, is to see when the acceleration and velocity have the same sign and when they have the opposite sign. I'm going to change my window so I can see a little bit better what's going on there. It's a cubic velocity. I am. Incorrect, yeah. How could you forget about that? Okay. Okay, so Mackenzie, the velocity is in blue and the acceleration is red. Okay, you see that they are both below the x-axis from 0 to 2.
So it doesn't matter if it's both are opposite.
There's nothing to do with it. Yeah, the sign of that. They have to be the same or opposite. Okay. Yeah. So let me just finish this concept with Mackenzie. So that means that from 0 to 2, time t equals 0 to 2, the object is speeding up. Because even though they're both negative, that just means it's speeding up by going away from it. Okay, so the first part of this answer is this is I, H is the graph. So speeding up is from, let's see, 0 to 2, and then there might be more, so I'm going to leave a little space. And then slowing, so now from 2 to 3 it's slowing down because the acceleration is positive but the velocity is negative, so they're fighting each other. So from 2 to 3 it's slowing down. And then it's speeding up from 3 to there on.
So,
means nothing. It's speeding up at an increasing rate, which is faster. If the velocity, this is a Mr. Labor concept, if the velocity and the acceleration are both negative, that means it's speeding up.
I get that. We're kind of doing that right now with our calculus. No.
So as long as the velocity and the acceleration have the same sign, they're speeding up. The opposite sign.
So my friend said, well, maybe I'll do this break on the
Well, because when I first had it, I couldn't see couldn't, it was like maybe 10 by 10, I couldn't see this, so I just,
Yeah, but there's all on one. What would it make you think of it small?
it just like zooming in,
What made you think of that?
because I couldn't see it. When I first looked at the graph, my window was this.
That's just my window, or my skill.
When I first looked at the graph, it looked like this, and I couldn't see what was happening there. So I just wanted to cut out all of this noise and make this the expanded.
Yeah, because I had it.
It's hard to see. Okay, now what?
Well, I like the down one. I need like all of them, because we
All
just
of
wanna
them?
help them, and they're helping.
So 5 the next one.
Yeah.
Okay. So this is an application of what we just talked about, and this is a little bit of a right. But we can figure it out because what do we know? Yes, but we're not gonna take the derivative. I know, I was waiting for that. We are not gonna take the derivative, we're gonna graph the derivative. Okay? And so here's the velocity, now I need the acceleration. Okay? Acceleration is the derivative of velocity, right? Okay? And so at this point right here, since my tangent line would be horizontal, that means that the acceleration would be 0. Okay? Everywhere to the left of that, the slope of the velocity curve is positive, so that means the acceleration is going to be positive. Okay? Right? I know. Everywhere to the, I know, it's weird, isn't it? That these have different, they're going in different directions. That's why these are important problems, because you have to expand your brain a little bit. Everywhere to the right of one, the slope is negative, it's going down. So that means the acceleration line is going to be below. Okay? So now we can answer the question about slowing down and speeding up. After 2, no, this is what Caleb and I are trying to get our brains around. We're not looking at the y values of this graph. We're looking at the slope of the graph. Okay? What's that? What when you say y? Because acceleration is the derivative of velocity, and derivative means the slope. No, because here the velocity is negative and the slope of the curve is also negative. And so here you're actually speeding up. Oh, okay. Okay, cool. So this is speeding up from 0 to 1. Okay, there you go. So speeding up from 0 to 1. It's slowing down from 1 to 2, because from 1 to 2 the velocity is positive but the acceleration is negative. And then from 2 to wherever, it's speeding up again. I guess we probably should say from 2 to 3, right? It's the third Yeah, we don't know what's going to happen. Yeah, it looks like the acceleration might be 0 right now. Yeah, they're the same, they're speeding up. Okay, so same thing with this one. No, it's not. Okay, so at 1, the acceleration is 0. And it's also 0 at 2. Okay? From 0 to 1, the acceleration is negative. Nice. Even though you're above the, yeah. Okay? It's negative, but it's getting less and less negative. The slope is leveling out as you approach this point. So the slope right here is a big negative number, and then it's a less of a negative number, and less of a negative number, and then zero. And then the opposite happens here. You start out with a very small positive slope, and then that slope gets bigger and bigger and bigger, and then it gets less and less and less until it reaches zero again at 2.
Not really how that works.
Yeah, it'd be a little parabola thing. When you think about this, this is a... Oh, no, I got a little too far there. But when you think about what your knowledge of derivatives, this is a cubic function. So the derivative of a cubic is going to be like that. Okay? What happened there? 0 to 1, the slope of this curve is negative. So I drew a line below the x-axis because it's negative. Okay? At 1, the slope is 0. Okay? Then the slope is positive between 1 and 2, but it has to be 0 again at 2. So I drew it going up and then coming back down. Alright? And then from there on, from 2 on, the slope of this curve is negative, so I just drew a negative. I drew it in the negative.
Why do we not say that we can go back up there?
Go back up where? When I hit 3? Because at 3, the slope of the tangent line is... Yeah. The acceleration... No. The acceleration is the slope of the tangent line, so you have to care about the slope. That's what this is. Instead of putting A right here, I might as well put M for slope. Yeah. I'm graphing the slope of the tangent line as I'm moving across.
The first chunk, that slope is negative.
Right. So here's the tangent line. Okay? Good luck for you viewers at home that can't see the ruler that I'm holding against the board. So this is a large negative slope, and then as I move across the thing, it becomes less and less negative until right there it's 0. That's what I'm trying to represent with this right here. Okay? Then it is slightly positive, so baby positive, and then bigger and bigger and bigger positive. Okay? And then once I pass that little point of inflection, now it is still positive but less. Okay? Until it reaches right here where it's 0 again. Alright. And then after that, it's baby negative, bigger negative, bigger negative, bigger negative, super negative, uber negative, 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 negative. What do you say? Oh, I wouldn't say that much. And all the way there. Okay? No. Oh. Okay. What? Okay. Okay, here's what's happening with the velocity. No, here's what's happening. This is your velocity, right? Okay? So, this way is positive, that way is negative. Alright? So, from 2 to 3 seconds, I'm going this direction. And then at 3 seconds, I come to a stop. And then I turn around, and then now I'm going this way, okay, after 3 seconds. And then I'm going this way, and I'm going this way faster and faster and faster. I'm speeding up from... It is. My acceleration, the absolute value of my acceleration over here is larger. Okay? We do that a bit. Okay. Right. Okay. Okay. Yeah, I was really proud when I thought of that. Okay. So from 0 to 1, they're opposite, so they're slowing down. So from 0 to 1, they're opposite, so they're slowing down. From 1 to 2, they're both positive, so they're speeding up. And then 2 to 3, they're opposite. Because from 2 to 3, this one is positive, but this is negative.
Oh,
so they're slowing down. And then from 3 to 4, they're both negative, so they're speeding up. Okay? That's crazy, and it's physics, and so it's smooth, but you know, it's in there.
What is the absolute value?
Okay. Were you here yesterday? To help with it. What do you think? Week 1 to We're not doing 6? Oh yeah.
Oh, yeah.
Oh yeah. 6 is this is the like, okay, now do you get it?
No, this will find out.
Yeah, we will find out, because now they're asking us the same question, but they're giving us the position function to start with. So we have to take the derivative of that to find the velocity ourselves, and then we have to take the derivative of the velocity to find the acceleration. Okay? So this is uber cray cray.
Why is this?
Because I care deeply about your future.
So is the bottom part you're doing, is that the velocity or the acceleration?
Yeah, so this is going to be velocity, and then this is going to be acceleration. Okay? Woo-hoo-hoo! All right, so at 1, this is the easy one. The velocity is 0. And at 3, the velocity is also 0. Okay. Testing. Testing. The magic word is pineapples. Okay, and then here the graph has a very large positive slope, and it gets less and less positive as we move along the curve. So it's starting here and then dropping down. All right. I know, it's tough. That's why we had to do these problems, to try to build that concept. Okay. Okay, then here the slope is slightly negative, okay, and it's going to get more and more negative, but then when it reaches its most negative-ish point at 2, then it's going to start getting less and less negative again until it comes back to 0. So it's going to be a little parabola like that. Okay, most negative-ish. So, and then here it's positive, positive, more and more positive, like that. Okay? So that's the velocity. Okay? And again, in your brain, you're connecting not only the concept of position and velocity and slope to tangent line, but hopefully you're also thinking about the fact that this original function appears to be the original one appears to be a cubic, which means the derivative should be parabolic, which it is. And so now we're going to look for what's going to happen next. It's going to be linear. We should see relatively linear. Okay? What just happened? That is amazing. Okay, so right here at 2, right here at 2 is 0. Okay, I'm going to change color so we can maybe see some better. Okay, so 0 at 2. Everywhere to the left of that, the slope is negative, and everywhere to the right of that, the slope is positive, and we were expecting a straight line, and that is darn tootin' what we got. What's the matter? Yeah. Ah!
No, not Barney the dinosaur.
No, Barney, the sheriff or whatever.
Andy Griffith's show.
Yeah,
Come
Andy
on. Who doesn't know that?
Apparently, you should be.
It's like saying what is the Gilligan Island? Oh, great
California,
show.
California California Highway Patrol.
You don't know who Ponch is? Oh my gosh, this is
Yeah,
all I want to
got it.
know.
Okay, so now that we have these graphs, we're ready to answer the physics part of the question.
What about
So from here,
Drop it.
from 0 to 1, this is positive, and from 0 to 1, this is negative. So they're fighting each other, so that means it's slowing down.
So you don't want it with the original, you want it with the velocity?
You always, speeding up and slowing down is velocity and acceleration. Then from 1 to 2, this is negative, and from 1 to 2, this is also negative. So that means it's speeding up.
We don't care about the tip light that makes
We don't care about
Right,
this.
okay, right
It's
now-
below the x-axis.
Yeah, so it's not the slope. It's
Nope. Now that we have the graph of the slope, we're looking at the y values of the point.
So back to the 0 to 1. The acceleration would be negative and the velocity is positive.
Yep. The velocity is above the x-axis. The acceleration is below the x-axis. Is it coming through now?
Yeah.
Okay.
No.
Sorry.
Like, Cameron had that break in his phone, and we were doing crazy and moving on the baseball,
Mhm.
and maybe it was his baseball, and his phone had something.
Uh-huh.
He's like, I love it.
And then he explained it and everybody else came along with him. That's
No,
awesome.
I just go on.
Okay, then from 2 to 3, the velocity is negative because it's below the x-axis, and from 2 to 3, the acceleration is positive, so that means
And
it's
then from
slowing
3 to
down.
infinity is speeding up.
Yeah, and then from 3 to 4, they're both on the same side, then
Infinity.
however you want to,
But is 3 to infinity correct?
3 infinity is fine. I'm going with 4 because the graph stops at 4. That's
That
all.
makes like that, but
Okay, so now let's see if we got it. Okay, with this last one. And the problem with this last one is that I don't know what that is. What kind of a graph is that? Cubic? Quartic? I don't know.
No, that's
Dumb.
where's your sign?
It's a dumb
Look like that.
graph.
Mr. Albert, where's your sign?
Where's the sign?
Yeah.
Oh, I took it then. That was, that
What,
was
it was dumb, Mr. Albert? Is that what-
setting a bad message. Well, this little section right here is quadratic, so we're going to expect that the derivative below this is going to look linear, yeah. Okay, so first find the velocity, yeah, and there's only one place where it's 0, and that's at 3 seconds. So here is highly negative, slightly less negative, and then back to negative again, and then even more negative. So it doesn't, this is going to be kind of rough because we need to make this correct for this to be correct. What's that? So this is highly negative, so I'm going to put a dot way down here. And then it becomes a little bit less negative at 1.
I didn't need to draw my acceleration graph next to it.
And then it becomes even more negative going to there. So there is sort of a hitch in the giddy up there, a little parabola.
So
Really negative, less negative, and then really negative again.
and really negative again too.
And then, I don't even know. And that's super
And then it-
negative, yeah. And then it bounces back out. Okay, so maybe a little bit like that.
Yeah.
And then it becomes positive, positive, positive. And like you said, this is going to be kind of a linear action there. That's a little bit rough.
It makes sense though. It's rough.
The problem is that they want us to figure out where the acceleration is 0 based on this rough graph that we drew, and that's kind of wrong. I'm going to say that it's 0 at 1. So positive,
Can we say 0 at
there's also 0 at 2. Okay, so positive, and then negative, and then back down here, and then positive forever. Okay,
So it's kind of like a little cup
kind of like a little cup
or a chipmunk.
or a beetle. Okay, so based on our little weird assumptions about the slopes of this thing right here, from 0 to 1, the velocity is positive and the acceleration is negative, so that means it's slowing down. And then from 1 to 2, they're both negative again, so that means it's speeding up. And then from 2 to 4, oh no, from 2 to 3, they're fighting each other again. And then from 3 to 4, they're both the same.
Let me get in the. Oh,
I
that
wanna-
was good.
No, but I just want to see if we were anywhere on that one, because that was the possible exception that we would just make up that.
Well, you, I think you are,
Need more purple.
That was number 6, B. Speeding up on interval 1 to 2 and on 3 to 4. So I get slow down interval 0 to 1 and 2 to 3.
Maybe we could do problem, go back to problem one and do that.
I have
you
no
do
idea.
I have no idea.
Let's just go take it and put it in our finger bucket. Oh.
Oh, God, he's polar. So, are you dumb? Yeah.
Go put it in our bucket.
No.
No.
We already have $700 in our budget.
There's a reason why we don't.
Well, it's that thing, so why not?
We already have $700.
Okay, if anything, if you
Yeah, but
need,
that's 250 right there, so that's.
if anything, we could either go up to the front.
First in our good place.
Oh, just go in, $50 for a bottom flat. I'm not gonna get that money, and that's a
That's
really nice
awful.
gift, I know, that's good.
No, you're awful.
Don't. You guys are moral for that.
I feel bad about myself.
No, I'm just excited that in the future high school, so you can do it.
I asked him to do number one for me.
Okay, so you guys take a break. Okay, the kids and I are gonna go through number 1
All
real quickly
bigger, but
together.
we can go on.
Okay, and then we'll go, yeah, that's fine. And then if we have time, we'll take a look at number 7. Okay? Alright, so Mackenzie, find the velocity at time t.
Minus 24 speed plus 36.
Okay, what is the velocity after 3 seconds? Feel like maybe -9.
You're alright.
Okay, what is the particle at rest?
So I have a question about that. What does that mean, that a negative velocity? Does that just mean it's moving at 9 feet per second away from us?
Yeah, this is a particle that's just moving back and forth, and so they're saying left is negative and right is up.
It's
So it's
moving 9
moving
feet per
negative
second
to
to
the
the
left.
left.
Okay, so to find out when the particle is at rest, you set that equal to 0. So I guess I just pause.